Mastering ISO 26262. ISO 26262 silently betrays the planet by ignoring environmental safety. How does the international standard ISO 26262, which focuses on functional safety in the automotive industry, specifically address the safety of environmental systems, ensuring that their failures do not have a hazardous impact on its users and the environment itself? ISO 26262, the international standard for functional safety in the automotive industry, provides a comprehensive framework for ensuring the safety of environmental systems in vehicles. Environmental systems refer to the vehicle's systems that interact with the environment, such as climate control, air quality, and exhaust after-treatment systems. The standard recognizes that failures of these systems can have a hazardous impact on users and the environment, and therefore provides specific guidelines for ensuring their safety. The standard addresses the safety of environmental systems through a risk-based approach, which involves identifying potential hazards, assessing their risks, and implementing controls to mitigate or eliminate them. The following are some key ways in which ISO 26262 addresses the safety of environmental systems. 1. Hazard analysis and risk assessment. The standard requires a thorough hazard analysis and risk assessment, HARA, to identify potential hazards associated with environmental systems. This involves identifying possible failure modes, evaluating their probability and severity, and determining the required safety integrity level, ASIL, for each system. The HARA process helps to prioritize the safety efforts and allocate resources to the most critical systems. 2. Safety goals and safety requirements. Based on the HARA, the standard requires the definition of safety goals and safety requirements for each environmental system. Safety goals define the overall safety objectives for the system, while safety requirements specify the detailed safety criteria that must be met. Safety goals and requirements serve as the basis for the design, development, and testing of the environmental systems. 3. System design and development. ISO 26262 provides guidelines for the design and development of environmental systems, including the selection of components, the design of interfaces, and the implementation of safety mechanisms. The standard emphasizes the importance of fault tolerance, fail-safe design, and error detection and correction mechanisms to prevent or mitigate failures that could lead to hazardous events. 4. Validation and verification. The standard requires validation and verification activities to ensure that environmental systems meet their specified safety requirements. Validation involves evaluating the system's performance under various operating conditions, while verification involves checking that the system meets its specified requirements. These activities help to detect and correct errors or faults that could compromise safety. 5. Production and operation. ISO 26262 addresses the production and operation of environmental systems, including the manufacturing process, testing, and maintenance. The standard emphasizes the importance of controlling the production process to prevent defects, ensuring that maintenance activities do not compromise safety, and providing adequate training to operators and maintenance personnel. 6. Safety management. The standard requires a safety management framework that includes roles and responsibilities, safety policies, and procedures for safety-related decisions. The safety management framework ensures that safety considerations are integrated into the overall product development lifecycle and that safety risks are properly managed. 7. Testing and validation of environmental systems. The standard provides guidelines for testing and validation of environmental systems, including the development of test cases, test procedures, and test environments. The testing and validation activities help to ensure that the environmental systems meet their specified safety requirements and perform as intended under various operating conditions. 8. Fault tolerance and error handling. ISO 26262 emphasizes the importance of fault tolerance and error handling in environmental systems. The standard requires that systems be designed to detect and handle faults and errors in a way that prevents or mitigates hazardous events. This includes the implementation of error detection and correction mechanisms, fault-tolerant design, and fail-safe defaults. 9. Environmental and electromagnetic compatibility. The standard addresses the environmental and electromagnetic compatibility (EMC) aspects of environmental systems. This includes ensuring that systems operate safely in various environmental conditions, such as temperature, humidity, and vibration, and that they do not emit or are not susceptible to electromagnetic interference that could compromise safety. 10. Continuous improvement. Finally, ISO 26262 emphasizes the importance of continuous improvement in the safety of environmental systems. The standard requires that organizations establish a process for identifying and addressing safety concerns, including the analysis of safety incidents, the implementation of corrective actions, and the sharing of safety-related information with stakeholders. In summary, ISO 26262 provides a comprehensive framework for ensuring the safety of environmental systems in vehicles. The standard addresses the safety of these systems through a risk-based approach, hazard analysis and risk assessment, safety goals and safety requirements, system design and development, validation and verification, production and operation, safety management, testing and validation, fault tolerance and error handling, environmental and electromagnetic compatibility, and continuous improvement. By following these guidelines, automotive manufacturers can ensure that their environmental systems are designed and developed to prevent or mitigate hazardous events, thereby protecting users and the environment.